Okay, today is September 5th. We are learning another method for solving linear systems today. So the last couple of days you've been doing substitution. I am absolutely confident you guys have a good understanding of substitution. I was very impressed with the work that you guys turned in yesterday, and I ended up like showing it off to other teachers because I was like, look at this good work, it's so good. It's amazing when it is all, in columns, it looks so good, and it's all, everybody did it. It was really, really cool. So I'm confident you know how to do that pretty well. We're learning another method for solving systems, and it's called elimination. It's dramatically easier, okay? The nice thing is for your test, which I think is next Friday, you'll, I think, maybe be tested on this stuff. I'm not sure. I might be off a week too. I'm not going to be specific. I don't care which method you use for solving your systems. You could solve by graphing, but it's not usually a good choice. You could solve by substitution. You could solve using elimination. It doesn't matter which way you do it. So you get to pick which method works best for you, okay? And so keep that in mind. Today we're also going to go back and talk about what happens to get no solution and infinitely many solutions. And so I want you to think back to when we were graphing. We were graphing lines, and where was the one solution? What did it look like if you got one solution? They would, one line, the other, where's the solution? Where they intersect, right? We would get one solution where those lines crossed. What does it look like when you have no solutions? What do those lines look like? They're parallel, yeah. So we have parallel lines. There are no intersection points, and so that's when we get no solution because they are parallel lines. And remember, I like this whole statement thing because I want you always thinking about what this actually looks like. Okay, it's really important that we get that visual in our head. There's no solution because there's no intersection. They're parallel forever and ever. What does it look like when we have infinitely many solutions? They're, lines graphed on top of one another. That's right. So we have, they are infinitely many solutions because they are the same line graphed on top of one another. And again, things that we want to remember. And I really like seeing the whole statement right now. Okay, so we're going to run across this today. Graphically, it's super easy to understand no solution and infinitely many solutions. Today, though, we're using algebra. And so I want to show you what it looks like for algebra, with algebra, when we get no solution and infinite solution. So here we go. Example 1. Solve the system using the linear combination method. You don't need to write that. Using elimination. This is the words out of the book. Most teachers just use elimination to describe the method. Solve the system using elimination. So again, I have a system. You'll notice this particular system, there's no easy variable, is there? Like a 1x or a 1y somewhere. There's nothing easy about it. When you don't see anything easy, elimination is a great method to use. So for elimination, our goal is just like the name of it. We want to eliminate one of the variables. You can see how everything is nicely stacked up here. We have all of the x's stacked up in a column. We've got all the y's stacked in a column. And then over here, we just have plain old numbers, okay? That's important. We want everything lined up nice and neat, okay? And then what I want you to do is I want you to look at your X column here, column of X's and numbers in front, and column of Y's and their numbers in front. Which column, X's or Y's, would you say has friendlier numbers? You all can do that. I haven't even told you what friendlier means, but you all have this understanding of what I'm talking about. I find that really remarkable. What do you think I mean when I say friendlier numbers? They're better together. That's cute. They're not negative. Okay, so maybe. They're easy. Why are these easier to deal with? They're divisible. Okay, so I know what you're saying, and the word you're looking for is multiples of one another. So 9 is a multiple of 3, meaning I can multiply 3 by a number and it's going to turn into 9. What can I multiply 3 by? I can, 3 times 3 will give me 9. So we say 9 and 3 are multiples of one another, okay? So that's what friendlier means. It means they're multiples of one another. And our job, we want to have opposite. Oh my goodness, I have to think about how I said that. Did a pretty good job. First time through. Sorry. All right, here we go. So the first thing we want to do is get opposite variables. Meaning we said, hey, let's look at the X column. And what we want to do is we want to make the numbers in front opposites. What are opposites? Like, what's the opposite of positive 5? Negative 5. Oh, you know that. Okay. So in this case, we want our X's to be opposites. I want to get a 9X and a negative 9X. I want them to be opposites. Okay? So what I'm going to do is I'm going to multiply an entire equation. What should I multiply this whole equation by? Negative 3. I'm going to multiply the whole equation by negative 3 because I'll have a positive 9x on top. And what would I get in the second equation? A negative 9x. And that's what I want. So we're going to get opposite variables by multiplying or dividing one or both equations. We can multiply or divide by any number we want. We can multiply through by positive 1. We can multiply through by negative 1. We can multiply through by a half. We can divide by 4. It doesn't matter as long as we do it to every single term in the equation. So I, in this particular problem, am not changing the top equation, 9x plus 2y equals 0. But I am changing the second equation. When you multiply, the biggest mistake is not distributing the negative 3 to every single term. So I'm going to multiply negative 3 times 3x, negative 9x, negative 3 times negative 5y, positive 15y, and then negative 3 times 17. 51. Negative 51. There we go. And then once we do that, so we've got our lovely opposites. That was our goal. The second step is to combine the equations. And I use the word combine on purpose. We're going to combine the 9x and the negative 9x. What do you get? 0. They cancel each other out, thereby being eliminated. Did you see that? That's some arms rushing. Okay, that's terrible. I used to be really good at it. I can't do it when I'm smiling. Okay. All right. We have a 2y and a 15y. What is 2y and 15y? 17y. And 0 and negative 51. Negative 51. So we combine the equations. Hey, that's a really easy equation. So now we're going to combine and solve it. Combine and solve. So how do I solve for y? Yeah, divide by 17, divide by 17.
Y equals negative 3.
y equals -3. How about that? That's pretty easy. Are we done? No, we're not done. What do we need to do with this value? Yeah, plug it back in. Plug it back in to solve for the other letters. So what we're going to do, I'm going to say plug back into an original. Plug back into an original equation. I encourage you always to use an original equation. Would you like to use the top equation or the bottom? The top? Okay. Does it matter which equation you use? Not going to matter. Doesn't matter which equation you use. So I'm going to take my 9x plus 2y equals 0, and I'm going to plug in my -3. Where do I plug the -3 in? For the y. So we're going to plug that -3 back into one of those equations, 9x plus 2 times the -3 equals 0. 9x, what is 2 times -3? -6 equals 0. And then how do you solve for x? Add 6. So I have 9x equals 6, and then what? Divide by 9, divide by 9. So we get x equals 2/3. Yeah, so this divides top and bottom. You can divide by 3. So we get 2/3. You will see more fractions today. What is the ordered pair solution? 2/3, comma, -3. Very good. Okay. So this is significantly easier. There is still tremendous room for error. This is usually the place where you forget to multiply the 17 by -3. So make sure you multiply everything. Okay? Let's try another. 11x plus 6y equals 1. 3x plus 2y equals -3. So I notice again, I've got my beautiful x column here where my x's are stacked. I've got my y column, my y's are stacked, and my constants over here, just plain old numbers that don't change. So look at those x and y columns. Which ones are friendlier? The 6 and 2. Yeah, 6 and 2 are definitely friendlier. So what can we multiply by? So they're opposites. -3. Very good. So I'm going to multiply the bottom equation by -3. That way I have a positive 6y and a negative 6y. I want them to be opposites. All right. So I'm not changing the top equation, but I am changing the bottom equation. What does the bottom equation turn into? -9x, right? Multiply. All right, and then -6y equals +9. 3 times 3. -3 times -3 is +9. Okay, that was our goal. Right here we have those lovely opposites. We're going to go ahead and combine our equations. 11x and -9x is going to give me what? We're adding these up. So 11x and -9x is 2x. There we go. What happens with +6y and -6y? They cancel out. We've got a giant equal sign. And 1 and 9? 10. Can you solve for x? Oh, yeah, good. We can divide by 2, so x equals 5. That's nice. Am I done? No, of course not. What do we want to do? Plug it back in to the top or bottom equation? The top one? All right, I'm hearing lots of top. Does it matter which one you use? Doesn't matter at all. 11x plus 6y equals 1. And what am I going to do with the 5?
Put it in for the x.
Put it in for the x. Very good. I like what I'm hearing. So we have 11 plugging in a 5 plus 6y equals 1. 55, no x. We replaced the x, right? Yeah. Plus 6y equals 1. And then what do we need to do, Ryan?
Yeah, subtract. So you get 6y equals negative 4.
Okay, subtract 55. So 6y equals negative 54. And then we can divide by 6. So y equals 9, negative 9. What's the order pair? Excuse me, order pair. 5, negative 9. Now, ladies and gentlemen, on this problem, we do have 2 more to do real fast, but I want to show you how to check. And you want to be able to check. And you can use your calculator. So I'm going to show you how to do that really easily. This is how you're going to get 100% on your next test. Every single one of you can get 100% on your next test as long as you check and make sure you did it right. So I'm going to take my calculator and I'm checking these answers. The x was 5 and the y was negative 9. So I'm going to go back to my original equations here and plug in for x and y. I'm going to plug in the 5 for the x and the negative 9 for the y. Whoops. All right. So I'm going to take my top equation, 11, and I'm going to use parentheses. What am I plugging in for x? 5 plus 6. And what am I plugging in for y? Negative 9. We said y was negative 9, so I'm going to type in negative 9. So I typed in the left-hand side here, and I hit enter, and I get 1, which is exactly what I was looking for. It works in the top equation. Now, it's not enough to just check one equation. I guarantee you I'm going to make a solution that does work in the first equation, but not the second, okay? So you need to check the second as well. 3, and what am I plugging in for x? 5 for x, plus 2, and what are we plugging in for y? Negative 9. So I plugged in the left side there, and negative 3, and that's exactly what we were supposed to equal. So easy to check on your calculator, folks, okay? Do it once or twice, 3 times to make sure you can do that on a test, all right? So very, very easy. All right, last 2 here. These are special cases. These are special cases that could happen during substitution as well. So pay attention to how the algebra works out here, what happens, and know that the same thing could happen if you were using substitution. 2x minus 3y equals 5. Negative 6x plus 9y equals 12. All right, ladies and gentlemen, I'm looking at my x column and my y column. Which column looks nicer? Doesn't really matter, does it? Let's pick one. I'm going to pick x's only because the numbers are smaller. All right, I want these to be opposites. What should I do so they're opposites? Multiply the top by 3. 3, yeah, okay. So I'm going to multiply the top equation by 3 and make sure that I'm distributing. So what does the top equation turn into? 6x minus 9y equals 15. Good. I didn't change the bottom equation. Negative 6x plus 9y equals 12. All right. Here's the special thing that happens. Positive 6x and negative 6x. 0. Negative 9y and positive 9y. 0. You must put something. You have to have a number. The number is 0. What is 15 and 12? 20. Does 0 equal 27? No, not on Earth. This is a false statement. What do you suppose happens when we have a false statement? No solution. Why do we get no solution for systems? Because they're parallel lines. I want you to remember that. No solution because they're parallel lines. These two lines are running like train tracks. Okay, good. Easy to tell when we have a false statement. Okay, next one. 6x minus 3y equals negative 3. 8x minus 4y equals negative 4. What should we do? Which numbers look better? Which column?
3, negative.
Okay, negative 3, negative 4. They're smaller numbers, right? Okay. And it technically is not going to matter, whatever you choose. What should we multiply, let's say, the top equation by? 4, okay. So what number are we trying to get to? 12, yeah, okay. If we multiply the top equation by 4, what should we multiply the bottom equation by? Negative 3. I love how you told me negative 3. Good. So let's see. We're going to distribute our 4. 4 times 6 is 24x. And then what do we get? Negative 12y. Good. And then last? Negative 12. Good. Bottom equation, distributing our 3 everywhere. Negative 24x. Positive 12y. Very good. Negative 3 times negative 4y gives me positive 12y equals positive 12. Interesting. All right, I'm going to go combine these. Positive 24 and negative 24. 0. Negative 12y and positive 12y. 0. I need a placeholder. I must have something. Negative 12 and positive 12. 0. True or false? True. This is a true statement. 0 always equals 0 all the time. Every day of the week. What do you suppose the answer is when we get a true statement? Infinite solutions. Why do we get infinite solutions? They're on top of each other. They are the same exact lines. You'll notice on this last one, I just want to point out, we multiply by 4 and multiply by 3. But if you look at these numbers, 6 and 3 and 3, couldn't I have divided by 3? Yes. And 8 and 4 and 4, could I have divided by 4? Okay. So you can multiply, which is usually what we do, but we can divide as well. And I want you to think about that, because certainly smaller numbers are always better. All right, do you have questions for me? All right, ladies and gentlemen, you can get started. I do want you to turn in whatever you get done today. You will not finish this assignment. I want you to work as hard as you can and get as much as you can done. Okay?
So do you have to use the stuff?
Today you definitely want to. You will get answers as fractions. Use your calculators to help you out. Math frac. Remember math frac?